Hello all, and welcome to this next video in the segment of image enhancement, where we are going to see some of the techniques of image enhancement in spatial domain. So here basically I will tell you the concept of point processing technique and neighborhood processing technique under spatial domain. So this is the book that we are referring to. In the earlier video, we have already seen what do we understand by spatial domain technique. So when we are dealing with the image its uh, in its spatial domain, in its raw form itself, and the manipulations are involved directly on the pixels of the image in spatial domain, such techniques are classified as spatial domain techniques. And when we transform the image from spatial domain to, say, for example, frequency domain, and then we apply some techniques like filtering in frequency domain, that type of techniques are called as frequency domain techniques, and later on from image from the frequency domain is converted back to spatial domain. So those techniques are classified as frequency domain techniques, and we go for such techniques because sometimes they are computationally more efficient, and sometimes they require less time for processing. But we will be coming to frequency domain techniques in the later sequence. So now, spatial domain techniques. The general formula for a spatial domain technique is given by g of x is equal to t f of x. Here, let me just enable my pen here. Here, f of x is our original image pixel value, intensity value, and g of x is the new image intensity value. It pertains to the new image. And this t is the transformation function. This equation means that some transformation on the original pixel value in the image is done so that we obtain pixel values in the new image or enhanced image. So this is the idea of spatial domain techniques, and the technique will depend upon the operator t. So f is the input image, g is the output image, and t is the transformation function. Now let us understand the concept of neighborhood in an image. So if I am referring to this particular pixel x comma y, then we have already seen this image in our earlier videos of fundamentals, where we know how to define these locations of this particular pixel, neighborhood of this pixel. So if this is x comma y, this is the x row, this is the y column, then this cell will be x minus 1 comma y minus 1, one row. This will be x plus 1 comma y minus 1 cell. Okay, so these are the 8 neighbors of this pixel x comma y. So this is the 3 cross 3 neighborhood of pixel x comma y, of pixel at location x comma y. Okay, so we have already seen this in the first segment of fundamentals. So as defined, this rectangular box is called as the neighborhood of x comma y, and then this neighborhood, for the operation in spatial domain, this neighborhood could be shifted and it could be convolved over this image to obtain the corresponding spatial domain output. So the procedure that is described here, it is called as spatial filtering. So this is our mask for the filter, and this 3 cross 3 mask in this example is convolved over this image to get a particular filtering operation. And what will be the filtering operation? That will depend upon the operator t. So that particular type of operation is called as spatial filtering. So now, in this neighborhood, the smallest possible size of this neighborhood could be 1 cross 1. And 1 cross 1 neighborhood means we are just talking about this pixel itself. So this pixel itself, it's its own neighbor. So we are just concerned about this pixel value. So when in the output image, the value at this particular pixel at this particular location changes with respect to the value of the pixel at this location in the original image. So when it is dependent on only this value of the pixel, then such an operation is called as intensity level or gray level transformation. Okay, or it is also called as point processing technique. So here in this case, for example, if this is my input image and if this is my output image, okay, image after enhancing, and if the pixel value here at x comma y is 10, and I want a new pixel value here at x comma y after enhancement. Now new value here, if it depends only on the value here at original image x comma y value, then that particular technique is called as intensity level technique or point processing technique. So here g of x comma y is only dependent on f of x comma y, and it is not dependent upon any of its neighbors. So such a technique is called as point processing technique, and T becomes the intensity transformation function. So your T becomes the intensity transformation because this intensity is transformed. So it becomes the intensity transformation function. So intensity level or gray level transformation techniques, they are simple mapping operations, and new pixel at a certain location depends only on the original pixel at the same location, and there is no change in size, geometry or structure of the new image as compared to the original image. So this is how point processing technique is represented, where R is the pixel of the original value and S pertains to the pixel of the new image, and T is the transformation function. Now there are three types of functions involved in intensity transformation or point processing techniques: linear point processing technique, piecewise linear point processing techniques, and non-linear point processing techniques. We will see about the details of these techniques in the subsequent videos. Thank you very much for listening.